So continuing, G, next item in our checklist is concavity and points of inflection. Compute second derivative and use a concavity test. What is a concavity test? Second derivative greater than 0 means the curve is up, concave up. Concave down where the second derivative is less than 0. Inflection point occur where the direction of concavity changes. Okay, so let's explain with an example. So this is item G, concavity. So what is the issue with concavity? If f double prime of x is greater than 0, then we are concave up. All right. Whereas if f double prime of x is less than 0, then we are concave down. Okay. What about inflection points? Inflection points are where concavity changes. Okay. Let's draw with a understand with a picture here. So concave up. So my curve looks something like this. Say it's concave up to begin with and then changes concavity, concave down. So this point where concavity changes, this is an inflection point. Okay. Here is another example. So this was a function which was increasing throughout, concave up, concave down. Okay. Let's look at a function that is decreasing throughout, right? So say you're coming like this, concave up and then concave down. Here is an example of another inflection point. Concavity changed from up to down. Okay. Now these were, this was a decreasing function. Now let's look at a decreasing function which starts, this is increasing. So let's start with first concave down and then up. Okay. So this is an example of an inflection point. Decreasing with concave down first, concave down and then up. So here is another inflection point. Okay. So this concavity is something you need to know to figure out how to draw your curve. See, increasing could be in various fashion. This is an increasing function, so is this. So you need to know something about concavity to figure out which increasing feature you use. Okay, so that's why you need the second derivative. All right, after concavity, you are done. The last step is to actually sketch the graph. Okay, sketch the asymptotes as dashed lines, plot the intercepts, maximum, minimum points, inflection points. So notice all of this information. What do we need? We need to sketch the graph. So this is the final step. H, sketch the graph. Okay. What are the things to be noted? Horizontal, vertical asymptotes are to be dotted. What else? Don't forget to point out the x and y intercepts. Don't forget to point out local or absolute maxima or minima. Then don't forget to point out inflection points. So all these are important features which must be pointed out in your sketch. Okay, so you have a long checklist here. You need to go through all of them. Let's start with an example. Okay, here we go. So this is a beautiful example. 2x squared over x squared minus 1. The first item in your checklist is the domain. x squared minus 1 should not be 0. That is, x must not be plus or minus 1. So you look at your line, number line, remove positive 1, remove negative 1, you are left with 3 intervals. That's your domain. So that was A. Okay. Next part is find the x and y intercepts. Okay, intercepts. To find y-intercept, set x0, find x-intercept, set y0. Okay, so here, if you notice, if you set y0, the fraction is 0, numerator is 0, x will be 0. So y0 gives you x0, x0 gives you y0. So x and y intercepts are both 0. Okay, 0. Now the next point to notice is symmetry. Are you an even function? Are you an odd function? Are you a periodic function? These are the 3 pieces of information you need. Well, turns out whenever you have only even power of x in your function, you will be an even function. You can plug in x equals negative x here and you'll get the same value because negative squares, negative squares. So this is an even function. That means whatever curve you draw on the right hand side, it will replicate on the left. Okay, next. Okay, next you're looking for limits at infinity. So why? Because after symmetry, you have to worry about asymptotes. For horizontal asymptotes, you're looking at x approaching infinity or x approaching negative infinity. So what happens if you take x approaching infinity, positive or negative infinity? Notice highest power of x you have to divide by. You divide the numerator by x squared, you divide the denominator by x squared, you get 2 upstairs, and downstairs you get 1 minus 1 over x squared there. Now when you let x approach infinity or negative infinity, this fraction goes to 0. You are left with 2. Aha, you got a number when you took this limit, which means you have horizontal asymptotes, both on the right and on the left. Okay. So on the other hand, when you already know x equals plus or minus 1 are problematic. So why don't we take limit approaching x from the 1 from the right, 1 from the left? You seem to get different limit infinities. One is a positive, the other is a negative. Likewise for negative 1, positive, negative. Okay. So you took care of the limits, so that gave us asymptotes. Horizontal asymptotes, vertical asymptotes. Note you have marked check marks because right hand limit here is positive. Here left hand limit goes to negative infinity. Right hand limit goes to negative infinity. Whereas here left hand limit goes to positive infinity. So you make these small check marks at the ends. Okay, so how did we arrive at all these? So notice we are looking at, first you looked at the domain, then you looked for symmetry, then you are looking for the limits at infinities, you are looking at limits at 1 and negative 1, and you get these different values. That helps you get started on just the dotted lines. Okay, next you find the derivative. This is quotient rule, derivative of square of the denominator, then on the top, derivative of the top, denominator as it is, minus derivative of the bottom, numerator as it is. Okay, anyhow, after cancelling etc., this is what you have. See where f prime is positive, using test points f prime is negative, and so on. Critical number, the only critical number is x equals 0. Okay, and finally second derivative, again a lot of calculation. This you'll have to do by hand, guys. That's how you know concavity. Okay, so there you go, this. Okay, that is each. All right, until let's see a few examples where slant asymptotes occur. That will be the next video.